So before we start looking at some examples of SpringWebFlux, let's first compare and contrast SpringWebMVC, which is the servlet-based approach we talked about earlier in the class, and WebFlux, which is what we're transitioning to now. And we'll talk about sort of the similarities and differences between these two platforms. So they have some things in common. You have controllers, you have services, and so on. And the difference is that the SpringWebMVC stuff is imperative. You tell it what you want it to do. And it's relatively simple to write because people understand how to do object-oriented programming with imperative logic. And there's a bunch of stuff here that you're probably familiar with, like Java, the Jakarta persistence API and the Java database connector and blocking operations and so on. And then on the right-hand side, we have all this sort of modern, newer, reactive stuff with functional endpoints and an event loop-driven model of programming, which uses a pool of threads, and some other technologies that are more non-blocking. But some things are in common, so you can have both of these things. So recall that WebMVC is synchronous, so the client makes a request. The request goes to the server. The controller mechanism works to take the incoming HTTP request, route it through this handler mapping component, which gives the incoming request to the appropriate endpoint handler method on the controller, which typically forwards to the service or the model, the database layer, and then the result comes back, and it comes back to the client. And what you typically have here is there's a thread that's dedicated for every request that comes in, and it typically comes out of a pool of threads. Now, we're going to talk shortly in our next example about how you can enhance the WebMVC model to move long-running processing off of the servlet thread. So that's a way to be able to more effectively deal with a large number of requests without running out of threads out of the servlet thread pool. But note that even in that case, the client still experiences a request-response blocking style of interaction. So this is kind of what it looks like. The requests come in from clients. They're handled by this servlet thread pool, which typically has a couple hundred threads. When there's a thread available, that thread is then used to handle the request. And if you need to access content out of other blocking resources, like a database, then that will also block as well. So there's some downsides to that, because how big do you make the pool? And do you either have lots of extra threads running around taking resources that aren't being used, or you end up not having enough threads? This, again, keep in mind, this is all pre-virtual threads. In contrast, WebFlux is asynchronous. And so the way it works is that clients hand off these requests to the underlying WebFlux core, which uses this reactive mechanism, and it runs an event loop within the number of threads, typically as many cores as there are on the machine as the number of threads in the pool. And everything takes place here in an asynchronous manner by registering callbacks transparently to you, because you're using reactive programming mechanisms. And all the stuff that takes place is running kind of in the background, asynchronously, and you never block. The code that you write on the server, and the client, for that matter, never blocks. So the idea here is to be able to leverage multiple cores effectively without having too many threads, and also to be able to handle a very large number of connections from clients. So that's kind of the driving force behind this model. So the way it works, it looks similar to what we saw before, but it's asynchronous. So requests come in, and there's a pool of threads, as many threads typically as there are cores, plus or minus a bit. And then those few threads process the requests, and there's no blocking taking place. Now, of course, for this to work effectively in a production system, you've got to have some kind of support for a reactive database, which, of course, we're going to have. And we'll talk about that. You'll get a chance to play around with a reactive database in Programming Assignment 2C. So ideally, completely non-blocking, better concurrency, better throughput with fewer resources in the form of threads. Okay, so the way this all works, of course, in practice is we have the endpoints in our controller return monos and fluxes. And they can also take monos and fluxes if you want, although you don't always have to do that. But they should return monos and fluxes instead of returning lists or regular Java types. Now, there's a couple different ways to do this. The most common way that we do it in the old school December 2022 model is by using something called Web Client. And Web Client is something that can be auto-wired. And basically, you can use it in order to be able to do asynchronous calls to server endpoint methods, endpoint handlers. And what will come back to you will be stuff that will be in the form of monos and fluxes. So that's how you do the asynchronous programming. If you want to stick with synchronous programming, which is what SpringWebMVC does, you can continue to use REST template, although this is kind of getting deprecated at some level because people are trying to move away from that kind of a model. And we'll talk more about that as well when we talk about the newfangled cool way of being able to do the proxies by using this thing called HTTP interface, which is actually also very new and better than retrofit, as you'll see. So REST template treats things synchronously, but it turns out that you can integrate this kind of processing with reactive servers. It just doesn't give you a reactive client. And if you get things back in a REST template, you can convert it back into a reactive type just by taking whatever you got back and wrapping it up in a flux, although that's not quite as good as having it be fluxes end-to-end. Web client, in contrast, is more effective since when you get stuff back, you can start to use it right away without having to wait for the whole thing to be marshaled. And that allows you to be able to get end-to-end asynchrony, where nothing is actually going to be blocking the whole way through the system if you have a client that supports this. Some clients struggle with that. And what's interesting is that the HTTP request in this model is not even generated until subscribe is called on the client. So when the client does a subscribe or block or whatever it does, that's when the requests are made. So it's a very lazy model, which is kind of interesting. What you see coming back is very similar. The encoding of the different formats is pretty much the same. The JSON encoding is similar for the reactive models as well as the more traditional reference types that you would get or list types you get with Java. So you can therefore use tools like Postman or curl with either of these models because they understand what is going on there. So that's a quick overview of SpringWebMVC and SpringWebFlux. We're now going to start transitioning to giving the bulk of the examples with SpringWebFlux so you can see how to use this new model.